그럼 지금부터 시작하도록 할 텐데요. 시작에 앞서서 오늘 함께해 주실 분들 소개부터 드리도록 하겠습니다. 먼저 토론을 맡아주실 좌장을 소개해 드리겠습니다. S&P 글로벌 커뮤니티 인사이츠의 마이클 스토퍼드 글로벌 가스 전략 수석님 함께해 주셨습니다. 박수 부탁드리겠습니다. 네, 고맙습니다. 네, 그리고 오늘 발표 세션의 연사님들과 패널 토론 및 질의에 함께 해주실 분들 소개해 드릴 텐데요. S&P 글로벌 커뮤니티 인사이츠의 션 카리 스리나바시 부사장님, 그리고 아이리나의 앤 캐터린 리퍼너 프로그램 부책임자님, 에너지경제연구원 이혜진 청정수소 인증연구실장님, 전력거래소 김건 수소정책부장님 함께 해주시겠고요. 이어서 제라의 마사토 오타키 저탄소 연료사업 기획이사님께서도 함께 해주시겠습니다. 또한 하이드로젠 컨슬의 다리아 노셰브니 정책 파트너십 과장님과 독일 연방경제기후보호부 팔크 베메케 과장님께서도 화상으로 함께 토론 및 질의 응답에 참여해 주시겠습니다. 네, 그럼 저는 지금부터 좌장이신 S&P 글로벌 커뮤니티 인사이츠의 마이클 스토퍼드 글로벌 가스 전략 수석님께 마이크를 넘기도록 하겠습니다.
Thank you very much indeed, and good afternoon to everybody, and thank you for rejoining us for this panel too, and to see us through to the end in the afternoon. It's my great pleasure to be joining the presenters and have a chance to interact with them and have a bit of a discussion on the presentations that we've heard from. First of all, I would really like to congratulate the KEEI on what I think has been an exceptionally well-organized and well-constructed event, so my congratulations to them. Secondly, I'd like to congratulate and thank all 7 speakers. I don't know about you, I'm sure you feel the same as me. I've learned a huge amount in the last couple of hours. This has been a fantastic education for me. But I am looking forward to some follow-up questions. You haven't quite earned your dinner yet, just a little bit more work for you to do there. I'd also like to thank the audience because, as has been mentioned, you did supply some questions at the registration. What I think was not mentioned was that over 100 questions were submitted, which shows the level of interest in hydrogen, and we've worked together to condense these down to about 10 questions that we'll address now to the group in various different order. I think where I'd like to start, when I come to Northeast Asia and here in Korea, and also with Jura on the panel in Japan, energy security is such an important topic. And I'd like to therefore address my opening question to Otaki-san, but I think that our colleagues from Korea and also our colleague from Germany from the ministry may want to chip in, but I'm going to start by asking the question to Otaki-san. Energy security concerns might remain in a carbon neutral Japan because of the dependence on foreign resources. So how does Japan think about strengthening your energy security even in a net zero world?
Thank you, Michael. My background is almost 2 decades in LNG industries. I used to suffering from such an energy security issue in the past. And energy security is yes, one of the biggest issues in terms of the decarbonization society in the future. So unfortunately, both Korea and Japan doesn't have the enough natural resources. And even though that we started this opened this new energy industries, energy market, I think a certain degree of dependence of the overseas supply is inevitable, I think. So what we can do is I think at least we need the collaboration between these countries like Korea and Japan, and how to enhance our energy security level. And also we need to diversify the supply source. So don't they focus on the one source of supply. don't rely on the one source. Diversify from the North America, Australia, and I think Middle East. This kind of the security or insurance is necessary in the future as well.
Thank you very much. I wonder, do we have Falk online joining us? I wonder if we have a comment about for Germany about how do you think about exchanging security of supply risk with Russian gas with supply risks within the clean energy sector? Are you with us, Falk?
Yes, I am. Thank you, Michael. I hope you can hear me well.
We can.
Perfect. Yes, I mean, energy security for Germany has become relevant, quite hard in the past years. And obviously we are looking at future energy security when it comes to renewable energy carriers like hydrogen. And that's why I mentioned in my presentation that our overall goal in the end is a global market. Because we are convinced if there is a global market, a diversified market with different suppliers, and we can have a lot of suppliers because for green hydrogen you just need sun or wind or both, then that is the best way of having security, because then you can replace a supplier if he is not able to supply for technical reasons or for political reasons or not willing to supply with another one. So this is really what we are looking for, and that's why we need partners like Korea, like Japan and others to build up that global hydrogen market that then actually works also for security. Thank you.
Thank you very much. Dr. Lee, Mr. Kim, I don't know if you wanted to add from the Korean perspective. Dr. Lee.
Yes. 그 독일이나 일본 측에서 이제 느끼는 바와 같이 그 세 나라는 사실 그 수소를 기반으로 한 탈탄소화가 굉장히 많이 필요한 그런 사회 구조를 가지고 있습니다. 그래서 이런 그 수소 사회를 앞당기기 위한 이제 정부의 노력이 반드시 필요할 수밖에 없고, 그런 측면에서도 사실은 기술 중립적인 차원에서 접근을 할 수밖에 없는데요. 그럼에도 불구하고 저희들이 아직도 특히 이제 LNG 내 업스트림 파트라든지 이런 부분들이 측정이 어려웠던 부분들에 대해서 개선을 시켜나가야 할 부분들이 굉장히 많이 있다고 생각을 합니다. 그래서 그런 부분들에 대해서 의구심을 해소해 나가고 또 더 투명성 있게 제도를 운영할 수 있도록 또 세 개 나라가 같이 공동적으로 협력을 또 해야 될 것으로 생각하고 있습니다.
Thank you very much. And Mr. Kim?
앞서 말씀해 주신 대로 이제 도입 수소 관련해서는 이제 연료 공급선 다변화라든지 뭐 연료 대비 안정성 측면에서 이제 그 어떤 지분 투자라든지 이런 부분들은 이제 저희는 활용을 할 수가 있겠고, 거기에 하나 더해서 이제 국내 생산 기반, 실제 수소 생산 기반을 국내에서도 이제 갖춰가지고 꼭 외국에 의존하지 않고 우리나라 자체적으로도 어떤 생산 기반 구축을 이끄는 것도 중요하다고 생각을 하고 있습니다. 그리고 일본과 같이 이제 우리나라는 이제 전력 개통에 있어서 이제 아일랜드 개통 섬 측면이 있기 때문에 지금 현재 재생에너지가 늘어남으로 인해서 이제 뭐 곳곳에 이제 개통 제약이라든지 이런 부분들이 이제 발생을 하고 있는데, 이런 제약이 나온 부분에 대해서 그 재생에너지 제약 부분에 대해서 이제 이 제약이 나온 자원들을 수소 생산, 수소 저장 쪽으로 활용을 할 수가 있다면은 적시적절하게 활용을 할 수가 있다면은 그것도 저희 에너지 안보 측면에서는 더 도움이 된다고 생각하고 있습니다.
And thank you very much for adding those thoughts. Thank you. I'm going to come back to you, Taki-san, with a slightly more specific question. I mean, you did give us an in-depth case study of the move to ammonia in a power station, but we've had a lot of questions about what are some of the technical issues involved in moving hydrogen ammonia power generation, and what are some of the solutions that Japan has come up with. Can you talk a little bit about some of the technical challenges to bringing in ammonia and hydrogen to power?
Yeah, 20% substitution project is just the kind of starter. So we, as I mentioned, so this is just the beginning. So we need the kind of enhance this activity towards the 2050. So currently, what we are doing is, succeed this demonstration test and as soon as possible. And also maybe the latter part of the 2020s or early 2030, we would like to, going up the substitution ratio 50% or higher. And finally, I think this is subject to the technology innovation, but 100% hydrogen and ammonia gas turbine technology is maybe the one of the potential solution in the future. So it's still subject to the technology, but we would like to see such the solution in near future.
Thank you very much. And just sticking with this subject, if I can come back to you, Mr. Kim, how do you see the electricity market in Korea having to adapt to bringing in ammonia and hydrogen? For example, how will the 11th basic plan on electricity have to adapt from the 10th?
네, 수소 도입과 관련해서 이제 저희가 이제 어쨌든 수소 수요를 저희가 이제 만들어내야 되기 때문에 그 부분을 이제 10차 전력 수급 계획에도 담았고 이번 곧 발표될 이제 11차 전력 수급 계획에도 이제 담길 예정인데 11차 전력 수급 계획 수소 분야에 이제 실제 참여했던 부분으로서 이제 말씀을 드린다면은 10차 대비해서는 10차 때는 이제 저희가 이제 뭐 혼소 발전이나 이 부분보다는 실제 연료 도입사 측면에서 도입 계획 측면을 그대로 저희 발전량 측면으로 이제 전환을 했었습니다. 근데 이번 11차 때는 실제 기술적으로 가능한 그리고 연료 도입적으로 가능한 발전사들의 의향을 기반으로 해서 11차 수급 계획을 이끌어냈고 그리고 향후 이게 혼소 발전이다 보니까 LNG의 수소 혼소, 그다음에 비율, 그다음에 석탄 발전소의 암모니아를 혼소하는 비율 이런 것들이 이제 나중에 향후 2030년대 중반에 가서 전체 전력 수급, 전체 전력 발전량과 이게 사실 이 매치가 맞아야 됩니다. 수급 맞아야 돼서 그런 부분까지 다 고려를 해가지고 이번 11차 전력 수급 계획에 수소 암모니아 발전량 부분이 담겼다고 말씀드릴 수 있겠습니다.
Thank you very much for that added detail. I think this next question, Anne-Catherine, if you'd like to take this on, but Daria, you may also have comments over the how do you, your presentation focused obviously on international trade, so I'm interested on how you see the potential of Africa and South America as promising supplies of clean energy.
Yeah, thank you very much. So there are different factors when we talk about potential for countries to produce and potentially also export hydrogen. So I mentioned the techno-economic potential to produce low-cost hydrogen, because of course when we talk about trade, we need to talk about who can produce hydrogen as cheap, that it's even cheaper, including transport costs, than producing and using locally produced hydrogen. So this is like the condition we are working with. And from a techno-economic potential, Sub-Saharan Africa actually has the greatest potential globally. Also Latin America has the potential to produce low-cost hydrogen. And the overall techno-economic potential to produce low-cost hydrogen by 2050 is 20 times higher than we actually need. But that's not the only thing we need to consider, right? So I mentioned also we need to consider what kind of product will be needed in the end on the demand side. So we need to look into the industries. We need to look at, do we need ammonia? Do we need methanol? Do we need e-fuels? Do we need actual hydrogen? Where does it have to go? What kind of pre-existing infrastructure is there, right? And how does the local energy system also look like? And we also need to ensure that the countries who will produce and eventually export are also benefiting from those new value chains. So to give you examples, I think that was mentioned earlier, Uruguay also already has a majorly green electricity-based energy system, positioning them very well. But we also have the case, for instance, for Kenya, where they already have a 90% renewable electricity-based grid, which is great. And then they were also looking, okay, what are our interests? And they also said, okay, we want to focus on ammonia production. And in the first phase, they are also looking for domestic use in order to substitute imports and fossil-based ammonia for fertilizer production, but also would like to expand that later in order to export green ammonia, which I think is a really good example how you can combine a global market approach, but also a domestic market approach from an exporting country perspective in a very sustainable way.
I tend to think of the advantage for green hydrogen as being based on good quality solar and wind resources, but not all of those areas on your map seem to show up, and you emphasized water constraints. Can you add a few details on that?
Yes, sure. So there are like some constraints, as I mentioned earlier. So we also have the constraint of water scarcity or emerging water scarcity. So we also need to consider not only who has problems with water available today, but due to climate change, where that might also increase. And this is why in the map that I showed with techno-economic potential, where water scarcity and also land availability, I would like to stress this here, because I think this is also an issue maybe in Korea or in Japan, where we can actually have land available to have large-scale projects, and water scarcity. There are solutions to it. So when we talk about water desalination, water treatment, there are solutions to it, but it will be a critical factor to assess where we can actually produce large-scale hydrogen production, and this is what you saw also on the map, considering this.
And one follow-up before I go to Daria. I think I picked up the phrase in your presentation, Anne-Catherine, about multi-carrier approach. Can you talk to that? Because it's a little bit surprising, perhaps, that faraway countries, even if they have an advantage in producing hydrogen, that can be compensated for by the cost of transportation?
There are also many dimensions to this, of course, but when we talk from a physical aspect, like hydrogen itself does not like to be transported over long distances, so this is the first constraint we have. And then also on the other, and maybe one thing, when we talk about pre-existing infrastructure, there are already ports handling ammonia, for instance, so this is an advantage for ammonia also. And also on the import side, I think Falk has mentioned that when we are talking about entry points, we also need the infrastructure for all the products in the entry points for importing markets, so that's also something we need to look at. And when I speak about multi-carrier future, I speak about the fact also that we have different demands for different products, and we need to have those value chains as efficient as possible in order to have this advantage also. And this is why I also talk not only about hydrogen, but ammonia, methanol, eventually also iron and steel, maybe. So this is what I mean when I talk about multi-carrier future. And especially the case of ammonia shows that reconverting ammonia to hydrogen in the entry point port might really decrease the efficiency highly.
I love that expression that hydrogen doesn't particularly like to be transported, but let me give you some encouragement. They used to say that about LNG, and now Korea receives LNG from the US Gulf of Mexico, from Australia, from the Middle East, so it can be done. But of course, the great advantage for hydrogen is this ability to transport it in other forms, notably ammonia. Daria, are you with us? Do you have some thoughts you'd like to share about supply sources across the world?
Sure. Thank you so much, Michael. Very happy to come in on the items that you have mentioned and that also Anne-Catherine has picked up on earlier. I think that maybe just first as a reflection on Latin America, interestingly, we see that in terms of the project proposals, Latin America is the second runner-up after Europe in terms of the total pipeline of projects that have been announced or proposed, amounting at nearly 85 billion. Now, of course, we see that there are fewer projects because of the project proposals in Latin America, in particular, sort of larger size projects based on higher share of gigawatt scale renewable upstream renewables that are being developed, in particular taking advantage of the hydropower reserves in Latin America. Now, of course, when it comes to final investment decisions, the region is at less than 1% currently. And we see that the project developers are still, of course, in the process of getting projects over the line, and especially, of course, struggling and trying to identify the offtake markets, and in particular the offtake markets in Europe. And we know that it's going to take some time until those mature. Maybe to pick up on the water dimension, I think it's an interesting area where Catherine gave a few examples, and I think we also see that there is an enormous opportunity to actually improve access to water, in particular thanks to building additional desalination capacity on the back of renewable hydrogen projects development in some of the countries in Africa. And I think at times there is this almost false dichotomy, between exports or local consumption. I think we have to be cognizant of the fact that for the local industries to be able, especially in emerging markets in developing countries, to be able to switch fuel, we do need to bring the cost down. To bring the cost down, you need to scale, and to scale, you need to export. So actually, in a lot of the emerging markets in developing countries, the development of the green industrialization and local hydrogen consumption ties and goes hand in hand with the development of the export potential because of the cost curves and the imperative for gradual scale up, and hence the ability of the local industries to access the clean hydrogen volumes. And maybe one more reflection, when we think about, we have spoken a lot about energy security, and I think that both in Asia and Pacific and in Europe, when we're thinking about energy security, we tend to think about the pipelines and, the import terminals. But another dimension to energy security is exposure to risks associated with the scarcity of critical raw materials that are necessary for the clean energy technologies that will provide the backbone for the energy transition. And the Hydrogen Council has carried out a dedicated study together with our colleagues in the World Bank, where we looked at the critical raw materials footprint of hydrogen as well as other clean energy technologies. And the results really highlight that the largest source of material demand across critical raw materials demand across the hydrogen sector really comes from the renewable electricity generating capacity needed for renewable hydrogen deployment. So this basket of materials includes, of course, aluminium, copper, zinc, and nickel, and others. We also find that ensuring the diversification of technologies, so using hydrogen solutions alongside, in particular, battery applications, will really help alleviate some of the supply chain constraints on the critical raw materials side, but also the exposure to the risks and constraints in terms of the availability of critical raw materials for the development of the clean energy solutions. So in short, really making sure that our transition to net zero is more sustainable and more circular, thanks to that deployment of hydrogen and fuel cell technologies alongside batteries. Thank you.
Yeah, thank you for bringing in the critical minerals on the supply side there. I think I'd like to go back to Falk. If you've got a couple of minutes, I know you're up against a hard stop, but if you're still with us, we can just squeeze in a couple of questions about Germany. There's a question of how are you doing relative to your ambitious plans of approximately 20 gigawatts of hydrogen power generation capacity? And what status report can you give us?
Well, thank you, Michael, for the question. Well, obviously, this plan was only announced at the beginning of this year, so it's a plan for the next 11 years, and I can't report that there are already power plants that are using hydrogen, but I can report that shortly after we announced the plan as a government, we heard some power plant providers that they have the technical plans to convert power plants to hydrogen use. We know there are hydrogen ready turbines that are being sold. So there is also a transformation going on in the power sector. because we're convinced to reach climate neutrality in 2045, we need these peaking power plants. I hope you can still hear me because
we can hear you loud and well, and I'm just wondering, can I just squeeze in one last question for you?
Go ahead.
It is about colours. Will the H2 global system consider other colours rather than green, and why is Germany so focused on one specific colour of hydrogen?
Well, obviously hydrogen doesn't have a color.
Good point.
But to make it a little bit easier, we call it green when we mean hydrogen produced with water through electrolyzers and using renewable energy. Because we're really convinced this is the sustainable option in the long run. And therefore, and it's not only us in Germany, but it's also the European Commission. So it's also true for the European Union that we believe green hydrogen is the sustainable option. And coming back to energy security, for us, the solution to increase energy security is transitioning away from fossil fuels and using renewable energy. That doesn't mean we don't want to import anymore, but we want to diversify our import base. And when it comes to H2 Global, our support instrument, we have made the decision if we use taxpayers' money, we want to use it for the sustainable option that we see. And I've mentioned it in the presentation, our markets are open. If you find an off-taker for other forms, then that's fine and nobody will prohibit it. But we're really convinced that in the end, green is the way forward. And that's why when we talk about financial support, we look at green. In the ramp-up phase, in the next years, we will probably need everything we can get that is considered sustainable or climate-friendly. But that's the ramp-up phase. If we look at 2045 and climate neutrality, we're convinced green is the way to go.
Thank you very much for that clarification, and thank you very much for joining us. Shankar, I will come to you, my colleague, in a minute, but I'm just going to follow up with some other questions before I come to you, if I may. Let's take the specific question about the Korea Hydrogen Certification Scheme. So for you, Dr. Lee, it's suggested, to my understanding, that there's no additionality requirement, which has been a huge discussion point, adding to complication in Europe, and I think now in the United States as well. Can you share some insights on that?
저희가 한국에서 인증제를 설계할 때 가장 이제 중점적으로 봤던 것들은 일단은 청정수소 생태계 활성화를 빠르게 가속화시키는 게 이제 무엇보다도 중요하다는 기반적인 생각이 있었습니다. 이거는 이제 한국이 지금 2030년 NDC를 만족시키기 위해서 수소를 대거 도입하는 것을 염두에 두면서 저희가 빠르게 생태계를 조성하는 것이 좀 필요한 부분을 염두에 두고 있고, 그러다 보니 일단은 많은 이제 투자비가 수반되는 부분이 이제 추가성과 관련된 부분이 대부분인데, 이제 이런 부분을 조금 더 완화를 하고, 근데 실제로는 이게 그렇다고 해서 추가성을 뭐 완전히 어겨라 이렇다기보다는 사실상은 신규 설비를 기반으로 해서 수소를 생산을 해야만이 사실상 더 경제적인 게 일단 일반적인 논리이고, 그럼에도 불구하고 저희가 어떤 니치 프로젝트라고 해야 될까요? 약간 어떤 부분들은 저희가 우리나라뿐만 아니라 전 세계가 세계적으로 에너지 전환기를 맞이하고 있기 때문에 어떤 이제 옵티마이제이션이 다른 부분에서 더 활발하게 일어날 수도 있겠다라는 생각을 했습니다. 저희가 그래서 이런 부분에서는 우선은 유연성 있게 접근을 하고 추후에 이제 상황을 흘러가는 걸 보면서 규제를 만드는 것이 오히려 더 바람직하다고 판단을 했기 때문에 이 부분에 대해서는 약간의 완화된 모습을 보이고 있습니다.
Thank you very much. You used the word flexible, and it sounds like a very pragmatic way forward. So thank you for clarifying that. Shankar, you've been waiting patiently. Let me come to you. There's a question about, will blue hydrogen be able to de-link from the price and volatility risks of the gas market, or will it be set by the gas price?
Well, I guess, yeah, that's a very good question. And I think, we saw some of the presentations and the similarities with the LNG industry and the indexation terms that were used for the LNG industry. So I think we would tend to think of it in the same sort of way. So the cost is going to be based on the gas price, and the value of the hydrogen is going to be based on what it's sold to as an end-use sector. So if we think about fertilizers or perhaps chemicals, perhaps you can pass through the gas cost fully. If it's the power sector, I guess it's going to be really dependent on what's setting the system marginal price. As I understand, here in Korea, gas is setting the price to a degree, so that could be a way of thinking about it. But really you have to think in terms of what is the cost of the hydrogen and the value, and that indexation really remains in between.
Thank you very much. Anne-Catherine, and I think Shankari as well, we've heard some very positive outlooks this afternoon about the growth of green hydrogen, but it has been facing some headwinds, particularly, I think, construction costs and high interest rates. What's your thoughts about that, Anne-Catherine? And is that going to slow down the convergence of green versus blue hydrogen?
So first of all, green hydrogen production will profit from declining renewable electricity, and they're higher. And in terms of electricity, even though we had also spikes there in recent years when it comes to manufacturing of supply, it's still getting the cheapest option also compared to fossil supply. So here we see a lot of room for optimism. Then when it comes to manufacturing of electrolyzers, we still need to see a massive scale up of that because here there's still a bottleneck. We see more and more big production lines coming up, so that's a good thing. But we need to ensure that this is also like getting down in terms of costs and also in terms of price spikes. We need to do that in order to get cheaper green hydrogen. And also, of course, we have room for innovation there also. And this is how we can, I think, counteract the spikes we have experienced.
Thank you. Daria, you may have a comment. Let me go to Shankari and then I'll bring you in, but Shankari first on costs.
Yeah, I think that's exactly the case. Right now we're seeing, electrolyzer costs are still 2 to 3 times, blue hydrogen costs. So we have to see some decline. First, the scale up, as you just mentioned, Katrina, in that the electrolyzer projects are still quite small. We have to see the scale, and they are coming. They're getting larger and larger, but as we see that pipeline build, we might see some learning rates there that are improving cost declines. I think I mentioned earlier, also the electricity feedstock. If you can combine renewables, if you can do offshore wind with solar, and you can lower that whole electricity feedstock price, that will help there. But at the moment, blue hydrogen is still much more competitive. So.
Okay. Daria, did you want to come in on
the
cost question?
Just to echo thank you. Just to echo the previous remarks, I think if we look at the estimated levelized cost of producing renewable hydrogen, if built today, it has been up by between 30 and 65%. Now, of course, there are multiple factors that have been causing this increase, including rising interest rates, higher cost of capital, increase of renewable power costs, importantly, as was mentioned earlier, in some cases by more than 30%, also higher labor and material costs, and also higher costs for building the balance of electrolyzer plants. But of course, the outlook for the cost decline towards the 2030s is positive, provided that we move forward with advancements in electrolyzer technology, economies of scale, and design improvements to the electrolyzers, and of course, ultimately, the fundamental component reduction in renewable power costs. But in the meantime, of course, indeed, low-carbon hydrogen, particularly produced in North America and the US on the back of 45Q, is particularly cost-competitive globally.
Daria, I wondered if you had a thought on whether we're going to see consolidation within the supply chain. Some of these companies are financially struggling, but at the same time, we need a massive expansion of the supply chain. Your thoughts?
I think we are in a stage where it's actually not dissimilar to the early days of wind and solar, when we will see a form of a natural attrition, if you like, or when the project pipeline and the pipeline of announcements is going to be narrowing down and the sort of we'll see the survival of the most cost competitive and robust projects and project consortia out there. So I think that the natural attrition that we see happening in the industry right now is actually something very positive, because that, again, the pipeline of very aspirational announcements was bound and has been bound to narrow down. And we see right now that market participants are able to combine different and basically come up with different approaches to project financing, combining debt, private capital, but also subsidies and support schemes, and industry consortia bringing together different market participants across the value chain are proving to be particularly effective, especially those that are targeting the global supply chains, making use of the most cost competitive sources of production, in particular in North America and Middle East.
Thank you very much. Now, what struck me listening to almost all 7, I think, of the presentations was the big emphasis on the international trade. A little bit surprised when we're trying to get this business off the ground locally to have such a big emphasis on international trade, but I understand the importance of it. I just had a rather specialist question for Dr. Lee. As you worked out your certification scheme, how did you think about whether that certification scheme fits into an international traded system, where one of the other speakers, I think it was you, Anna-Katrine, used the importance of interoperability? How does that work?
우선 전 세계적으로 이제 최소한 이제 웰 투 게이트 혹은 이제 웰 투 휠까지 배출량 산정 범위를 확대를 하면서 사실 각 나라의 전력 배출 계수라든지 어떤 특정 원료를 이제 조달하기 위한 방법론이 이런 거에 따라서 배출 계수라고 하는 이제 LCI DB가 매우 다릅니다. 그래서 거기에서 오는 차이가 인증의 임계점을 설정하는 데 주요한 차이를 가져오고 있다고 판단을 하고요. 다만 지금 이제 보면 각 나라에서 서로 발표한 임계점이 서로 다르더라도 사실상 분류수소를 최대한의 노력을 기울인 분류수소를 허용할 수 있는 범위로 값이 설정되어 있다는 것은 동일하다고 생각합니다. 그래서 어떤 이제 비즈니스 섹터에서 서로 다른 그런 기준들 때문에 혼란이 있을 수는 있겠지만, 사실상 제가 봤을 때는 기술 기준으로는 이미 동일하다고 판단을 하고 있고요. 그래서 그런 부분들에 대해서는 이제 저희가 상호 노력을 해 나가면서 기술 기준을 맞추고, 그리고 이제 DB의 차이점을 이제 서로 확인해 나가면서 이게 점점 개선이 될 것으로 생각을 하고 있습니다. 그래서 많은 전문가들이 협업을 해야 될 것입니다. 네.
Anne-Katrine, I think you wanted to jump in there. Thank you, Dr. Lee.
Yes, I would like to stress here that it's not necessarily a problem that we see different thresholds. This is not, I think it's very fair. So we have different regions with different approaches, and that can be translated into different thresholds. What we need in order to have a more interoperable system is transparency on how things are calculated in order to fit in the certification schemes, right? So we need transparency, and also we need a clear understanding what kind of data is being used. Is it first-hand data? Is it second-hand data? Those kind of things. And I think exchange here can really help in that regard, because they do not have to be the same, but we need to understand how they're being made.
Thank you very much indeed. Just to wrap things up, I think one final question that I'm going to direct to Shankri and Daria, and it's about game changers for the future. What possible game changers should we look out for around 2030, 2035? And the question is put here, particularly as countries are thinking about their new NDC commitments for 2035. So what kind of game changers might we see? Daria, do you want to go first?
Thank you, Michael. I think actually a real game changer, and this is something that has also been, I think, captured in multiple reports that are out there, would be to ensure that countries really focus on the rollout of the demand-side measures. This is something that I've mentioned in the presentation, but we see that firming up the demand by mandatory incentives, mandates, quotas, CFD schemes is absolutely critical, and it can create ripple effects across the whole supply chain. So I think ensuring clarity and certainty of the demand side measures in particular will be a real game changer that will catalyze the market, and that would also fuel competition between regions in accelerating hydrogen deployment.
Thank you. Game changers, Shankari?
Well, I think, the real challenge is still costs, right, for all clean fuels and especially for green. We've been talking about blue and green, but perhaps if one of the technologies that we haven't mentioned, like methane pyrolysis, where you're splitting the methane molecule and carbon black has a value, if one of these or many others could bring a step change in costs, that would make a significant difference as well. But I think, Michael, I'd just like to add that, I think there's still a bit of a debate perhaps about whether we're in an electron future based on electricity or a hybrid future based on molecules with hydrogen. By 2030, 2035, that would have really played out, and I think we'll have a much clearer view on molecules. And hydrogen CCS will have either succeeded in a very large way or perhaps be a niche contributor. I think we all believe that hydrogen can play a very large role indeed. So.
Thank you. I think that's a great place where to leave things. As we've heard from all the speakers, hydrogen is absolutely essential for the successful energy transition, but the size and success of its role is likely to be a good deal clearer in the early part of the 2030s, where we'll see whether it can meet some of the more ambitious targets or whether it will have more of a modest role to play in the energy transition. But a role to play, it most certainly will have. And thanks for getting in a little mention. No hydrogen conference discussion is complete without mentioning pyrolysis, so thank you for getting a mention in there. That concludes our discussion and debate. I hope you benefited from this great exchange of thoughts. Please show your appreciations to our 7 speakers. And finally, my thanks to you for making my job so easy and providing a great set of questions. Thank you. And that concludes this session.